Today we're actually going to start talking about proofs. I know it says properties of angles, but we're actually going to start writing proofs today, which is a very, very important concept that we're going to get into. Now, before I start this, I just want to make sure if you are absent from today, you have to make sure you actually print off the postulates and theorem sheets that are actually provided right after the link to this blank lesson. So there's two things. There's a lesson and then there's a proofs and theorem sheet. You need all of that to actually finish this homework and finish this lesson. So if you haven't printed that off yet, go ahead. Otherwise, pick it up tomorrow in class. There'll be one waiting for you. All right, let's go ahead and get started. So the first thing is basically a proof is all the stuff we've been doing in our head. When we solve a problem or something like that, we go through a key set of steps in order to solve it. The only difference here is I actually have to show all the steps and I have to describe why I can do each of those particular steps. So when we're writing a two-column proof, you're going to be provided two things. They're going to give you some information. That's going to be called your given. And they'll have some words after that, something, 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 something. And then they'll ask you to prove something. Now, over here, we're going to have two columns. These two columns are basically going to be your steps and your reasons. Now, normally the steps isn't called steps. It's just what I kind of think in my head. Normally, we're going to call these our statements. But you can think of them as your steps that you're thinking through so you're actually solving the problem. Then what happens is we actually physically put numbers down on each of these. Now, your very first reason is almost always your given. So you literally take whatever's here and you put that in your first, or I should say we actually put it right here and we list that was our given. That's what I was given. And then we kind of work our way down in our steps and we make sure our reasons match up with our steps as well. So 2 will match up with 2, 3, and 3, so on and so forth. And we're just going to keep going, etc., until we get to our proof. Once we prove something, then we are done. Same thing over here. We just keep going, etc., etc. Now, what's happening over here is we're actually using definitions of things. We're using postulates. We might even use some theorems. All right. So these are basically what we're going to put on this side, just saying why we can do what we can do. Let's just pop into an example and see what kind of it looks like. So you should have a sheet that looks something like this. The very first sheet has our properties of algebra and our properties of equality. These are going to be great anytime we're trying to solve a particular problem for X or Y. So let's look at our very first one. Writing an algebraic proof using a T-chart. So the first thing we're doing is we're given a given, obviously. We start with that. And we want to get to that. Now we're going to do all the steps we normally do. Well, first of all, we have to list why we can do stuff. So our first step was actually given to us. We're going to write step 1, reason. Hey, you gave it to me. I'm going to write it down. Now step 2. Step 2 is usually, if I was going to solve this, I would actually distribute that -4 to both things, which is actually going to result in a -24x minus 8 equals 64. Now we've done that a million times. However, this time we have to say why we can do that. And if we look back over here, it's actually we have a problem for it. It is called the distribution problem, that I can actually distribute something to things within parentheses. So we actually have to write that down. So we're going to put distributive property. Okay, now there's a couple things we could do. We could move the 8 to the other side. We could move, well, actually, that's probably the first thing we want to do. So what we're kind of doing in our head, we don't usually write this down. This is usually happening in our head where we add 8 to both sides. It's okay to write it down. Just make sure you have room to write your next step clearly below it. So our actual next step is we would have -24x equals 72. Now look what happened. What allowed us to add something to both sides? Once again, we have to look to the sheet and we need to look at what allows me to do that. Well, what allows me to add something to both sides is our addition property of equality. It says if A equals B, then A plus C equals B plus C. Basically, we can add something to both sides as long as it's the same thing. Note we added that A, we added that B. We are allowed to do that. So we're allowed to add something to both sides. All right, so that was my additive property of equality. I usually shorten that to add property of equality, add PO. Property of equality just means I'm doing something to both sides. That leads us to our final step. Once again, I'm just picturing this in my head. It is okay to write it down. But anything in red, I'm kind of thinking of in my head, and I'm just going to end up with x equals -3. Well, look, that's where I wanted to get to. But we have to describe what happened in that step. So to get to there, the addition property of equality allows me to add to both sides. So our division property of equality, if you look back at that sheet, allows me to divide the same number on both sides. I do want to note something. If you kind of look at it, it seems like a little weird. So step 2 to get to step 3 is additive property of equality. So step 2, going there, I added to both sides. So this step is almost happening down below it. So just be careful where you write stuff. How you got from step 2 to 3 is right here, is your third step. How you got from step 3 to 4 is your fourth step. So just make sure you're writing the right steps and you're following your train of logic, and you'll probably be okay on these. I do want to note before I move on, this sheet, or all of these sheets, you are allowed to take little notes on. We'll talk more about that in class, but you can take little notes on it as long as you're not doing an example, and you'll be able to use these on any test. All right, postulates and definitions. So this is, I'm using statements to actually prove it. And a postulate or definition is a statement that is accepted as true. We use postulates like properties of algebra to justify steps in a proof. So below we have used postulates or definitions to justify the given steps. So this isn't actually a proof. These are just building up to giving a proof. What allows us to do something? So first of all, we are given BE as a segment. So our statement number 1 says BE is a segment. Well, anytime we're using what was given, we're just going to write given right next to it. That's the reason I can write it, is because you told me I can write it. All right, the next thing is draw G as a midpoint of BE. So our next step on this would be to actually draw a G right smack dab in the middle and say it's congruent. Now, what actually lets us draw G as a midpoint of BE? Well, that's going to cause us to look further down. And if we look here, if we look at the midpoint postulate, it says exactly one midpoint can be constructed on any segment. It sure sounds like what I just did. It sounds like I constructed a midpoint on that. Well, this midpoint postulate says I can do that. I can draw exactly one midpoint on any segment. So that means I'm going to go back here and I'm going to say, well, the midpoint postulate let me do that. It allows me to construct that midpoint right there. Another example of just following directions is this one. It says point C. I know my lines and stuff could kind of get messed up on my iPad, so I drew over them. But you can see that point C, not on AF, so that was a line signature. And our statement, our first statement is point C is not on AF. Well, once again, that was given to me. You said I can do that, so I'm going to say, okay, given. You told me to do that. I did it. That's my given. Our next one is drawing a line through CT, or a line CT that is parallel to AF. So what they're asking us to do is they're asking to draw this line. And it says it's line CT, so somewhere on this line we do have to pick a T. Doesn't matter where, I could put it there. I could put it there. Doesn't matter as long as it's on that line. So usually I'm going to keep it in alphabetical order, so I'm going to put the T after it, but it's not a big concern. All right, now we're going to look for something that says I can actually construct that line parallel to another line. Well, if we kind of stick to that exact same sheet, just right below that midpoint postulate, we have this parallel postulate. Note that a lot of these postulates allow for construction, and constructing. So if I'm constructing something, I'm probably going to use one of these postulates. Well, if we look at that parallel postulate, it says through a point not on a given line, exactly one line can be constructed parallel to the given line. That sounds exactly what I just did. I made a parallel line through a point that wasn't on the line. So we come back here and we go, well, that's a parallel postulate. All right, but once again, those last two weren't really proofs. They didn't tell me what I was showing. They just gave me two steps, two logical steps, and I had to fill in the blanks on why I could do that. On our next example, we are actually going to prove something. So we are given that t is a midpoint of yu. So t is a midpoint of yu. Now, we come down to our statements, and I repeat that exact same thing. Your first step is almost always to repeat the given, word for word. And then all you have to do is you write given. All right, they're saying basically this is a two-step proof. When you start doing it on your own, you're going to not have these numbers. You won't know what you need to do. But let's look at what we need to show. We need to show that yt is congruent to tu. Well, that makes sense because I said midpoint. But now we have to show why that's true. So our step 2 is actually going straight to yt is congruent to tu. And what allows us to say that? Well, whenever we're trying to explain something that's true, say I say something is a midpoint. If I tell you something is something, your goal is to actually find that definition. So as soon as I say something is a midpoint, you're going to go to your definitions and look what it means to be a midpoint. Well, the definition of midpoint is a point that divides a segment into two equal segments. And I want to point out this. It divides a segment into two equal segments. So the definition of a midpoint says that it divides it into two equal segments. Well, just looking up the definition of midpoint is actually our next step because it says that both of these segments must be congruent. So we're just going to put definition of a midpoint. I'm going to tell you one of the easiest steps to do when you're doing this proof writing is if I tell you something is something, look up its definition because most of the time that is your next step. So if I say something is an angle bisector, if I say something's a midpoint, if I say something is congruent, you're going to look up the definition of that and that's usually your next step. In fact, you're going to see the exact same thing in our next example. So our next example says AT bisects angle CAR. In fact, there's a slight mistake on here. It's not really a big mistake, but usually we talk about rays when we talk about bisectors. There's nothing wrong about a segment bisecting an angle, but typically speaking, we talk about rays. So you don't necessarily have to make that change, but it makes it look a little more appeasing to what we talk about as an angle bisector. All right, so AT bisects angle CAR. Once again, before I do anything else, I'm just going to go bloop. I'm going to throw that down there, and then I'm going to say, you know what? You told me I can write that, and so I'm going to, and so that's going to be my given. Now, I'm telling you right now that AT bisects CAR, which is shown right here. 99% of the time, you are going to look up what it means to bisect something. So you're going to go straight to your definitions, and you're going to look up angle bisector. So without even looking at what I need to do, I'm going to look up what angle bisector means, and that is a line that divides an angle into two equal angles. That means, without looking, I probably think my next step is showing that two things are equal. And that's exactly what they want me to prove. They want me to prove that these two angles are congruent. In other words, they want me to show that CAT, which is here, is congruent to that angle there, TAR. So that is my next step, is actually to write that. CAT is congruent to angle TAR. And that was because I went straight to the definition of what it means to bisect, and I can write that down. Definition of an angle bisector tells me that as soon as I say the word bisect, it bisects it into two congruent angles. Just like our segment bisector or a midpoint divides it into two equal and congruent segments. All right. Just so you know, for your homework, if you're looking at the next page 27, if you look at those first two examples, those aren't actually proofs. In fact, the first 4 aren't really proofs. We start getting into proofs about step 5. 6 is kind of like what we just did now. 6, 7, 8, 9, pretty good. 10. If we start getting to the backside, number 11 is a little harder because I didn't even tell you how many steps it's going to take. And then 12 is a challenge question. We haven't even talked about any of these. Most of these are going to fall into our definitions or our early postulate sheets. In number 12, you have to dig deeper. If you get stuck, 100% okay, this is the very first day we're writing proofs. They can be very difficult once I'm not talking about them. So as always, just check the answer key and see if it helps you. If it doesn't at all, come to class with plenty of questions. All right, hopefully I can see you tomorrow and we can talk through this.